So let's graph x minus h squared. Now remember, the way you want to do this now is to find the vertex. So we talked about the vertex last class period. What's the vertex of this quadratic function?
The origin? Equal x squared.
What's a vertex?
That's zero. Sorry, 8 on 0.
8, 0. It's 8, 0. I know there's nothing I can do with it. It just keeps moving. All right, so 8, 0. Eventually it clears out. So the vertex is 8, 0. All right, now notice how some of you were struggling with this vertex. I need for you to go to that video from the last class period and look at it again. You need to look at it again if you were struggling with this. So remember we talked about the parent function. What's the parent function here?
Y equals
Y equals
X minus 2.
the parent function is x squared. See how some of you are still not knowing what the parent function is. I need for you to look at that video from the notes from last class period. Okay? So some of you are not. You've got to do this. Otherwise, you're gonna not know what these terms are or how to find them. So the parent function is x squared. Y equals x squared. That's the parent function. So remember when we graphed this, this was the parent function, y equals x squared. Its vertex is at the origin. For the one that I'm trying to deal with, x minus 8 squared, that's what kind of shift? That was one of the last things we talked about. Is it a horizontal shift or a vertical shift? It's horizontal because it's on the inside. If the number was on the outside, it'd be what kind of shift? Vertical. Well, the number's on the inside. And it's counterintuitive of what you think if it's a horizontal shift. So you see that negative 8? Now next semester you're going to learn why it's counterintuitive. But for us, just remember it's counterintuitive. So if you see that negative 8, think what kind of 8 then? Positive. So that means you can go to the, you're going to move the vertex or you move the graph to the right 8, right? 1, 2, 3, 4, 5, 6, 7, 8. So what's the vertex? 8, 0. 8, 0. So the vertex is 8, 0. So, hey. Yeah. Here you go. All right, so the vertex is 8, 0. That's the first thing you're going to find. Once you find the vertex, then we pick 2 points to the right, 2 points to the left. All right, so on your grid paper, the way you would do this is you would say, all right, here's my vertex, 8, 0, right? And I pick one more point, actually 2 points to the right, 2 points to the left of that vertex. So give me an x value that's to the right of that vertex. 9. 8 is a vertex, so don't use 8. Move to the right. Okay, so x is 9, so then we use a t-table. And so I get y equals, remember f(x) means the same thing as what letter? Y. So y equals 9 minus 8 squared. What's 9 minus 8? 1 squared is 1. So I plot the point 9, 1. Use symmetry. So if I went 1 unit to the right and got the y value of 1, we learned last class period that if I go 1 unit to the left, I'm going to get what y value? Guys, if I go 1 unit to the right, when x is, no, we're not good. Okay, listen. When I go 1 unit to the right, what was my y value? 1. If I go 1 unit to the left, when x is 7, what's my y value? 1 as well. That's what we talked about. All right, now I need one more x value to the right. Give me an x value to the right. 11, all right, if you want to use 11, that's fine. If x is 11, I get y equals 11 minus 8 squared. What's 11 minus 8?
2.
3. 3 squared is
9.
9. So I get 11, 9. So that's here. Well, if I went, notice I went 1, 2, 3 to get the 11, right, from the vertex? So if I go 3 units to the right, I got what y value?
9.
If I go 3 units to the left, 1, 2, 3, x is 5, I'm going to get what y value? 9 as well. And check it. Check it. When x is 5, I get y equals 5 minus 8 squared. What's 5 minus 8? Negative 3. And what's negative 3 squared? 9. All right. And then you just draw. Now what's this shape? A parabola. The shape is a parabola. Okay? And so that's the graph, y equals x minus 8 squared. Okay? Now again, next semester, the quadratic functions that you're going to end up graphing will be more complicated than what you see here. But there are formulas you're going to use. Okay. Now let's look at this one. Let's first of all, we're going to graph this one. Now remember, this is what kind of function right here that I just dealt with? Quadratic. That's a quadratic function. All right. So if I want to graph y equal absolute value of x this time. All right, y equals absolute value of x. Okay, so remember last class period, y equal x squared, that quadratic function, y equals x squared, we call that our parent function. So we're going to do the same thing here. Y equals absolute value of x is going to be called my parent function. So this is the parent function. And this is called an absolute value function. So this is the parent function of absolute value. So what's the parent function of a quadratic function? Y equals x squared. That's that transparency I kept dealing with. What's the parent function for absolute value? Y equals absolute value of x. Okay? All right, so remember when we first dealt with the y equal x squared, I drew a t-table with some points for x, some values for x. I'm doing the same thing here. And then we're going to use the idea of vertex, it has a vertex, and symmetry. The information here is the same as before. It's just that the shape of the graph is different. It has to be different because this is quadratic, whereas this is what? Absolute value. They're different functions, so the shape is different. But finding the vertex and finding whether it shifts to the left, right, up, or down is the same thing as the quadratic. Nothing's changed. All right, but for this one, let's just go ahead and use a t-table for right now. So if x is 0, I get y equals absolute value of 0. What's the absolute value of 0? 0. All right, so remember, the absolute value of a number measures the distance that a number is from 0. So basically, the absolute value of 0 means if this is my number line and this is 0, remember, the absolute value measures the distance that a number is from 0. So for example, if I have the absolute value of 2, if this is 0, here's 2, what's that distance? 2. What's the absolute value of negative 3? 3. So this is 0, this is negative 3. The absolute value means the distance that that number is from 0 on the number line. That distance is also 3. So the absolute value of number is always what kind of number? Positive. It's a positive number, unless it's the absolute value of 0, which is just what? 0. So that's 0, that's 2, and that's what? 3. So the absolute value of a number is always positive, unless the absolute value is 0, which is 0. So if x is 0, I get the absolute value of 0, which is 0. If x is, let's say, 3, I get the absolute value of 3. y equals absolute value of 3, which is what number? What's the absolute value of 3? 3. If x is, let's say, negative 3, I get y equals absolute value of negative 3, which is 3. If x is 5, I'm just picking some numbers for x. If x is 5, I get y equals absolute value of 5, which is what? 5. If x is negative 5, I get y equals absolute value of negative 5, which is 5. All right, so that's what it looks like, the values. Then, now some grid paper for you. You need grid paper. So then you just plot those points. You plot those points. So 0, 0, 3, 3, negative 3, 3, 5, 5, and negative 5, 5. All right. What do you notice about these points that are on this side of this? Now, this can be the vertex right here. What do you notice about the points that are on this side? They lie on the same line. Except it's not really a line, it's a ray. Because remember, a line has 2 arrows. So this is a ray. It actually looks like this. So it's not a curve. The absolute value is a curve. I'm sorry. The quadratic function was a curve. The absolute value is the shape of a V. Shape of a V. Looks like this. So that is the absolute value function. It is a shape of a V. So it's 2 rays that connect together at the vertex. Okay, so the absolute value function is not a curve like the parabola. It's 2 rays. It's formed by 2 rays. All right. And yeah, a ray. Like in high school geometry, R-A-Y-S. R-A-Y-S. So here is the shape here, the blue. We're going to use that idea again. So right here. So everything's the same as before. The horizontal shifting, vertical shifting is the same. Okay, we're going to do the same idea. But you got to know that the absolute value is the shape of a V. Quadratic function has what shape? What's that called though? Parabola. Parabola. All right, so let's look at this one. Let's suppose you want to graph y equal absolute value of x minus 3. Y equal absolute value of x minus 3. That. All right. Everything's the same as last class period. Let's find the vertex. And before we find the vertex, we got to ask ourselves, is this going to involve a vertical shift or horizontal shift? Vertical. Because where's that number? It's on the outside of my parent function. So that's a vertical shift. So this is going to involve a vertical shift. And basically what you're going to do is you're going to take that parent function. That's the idea. You're going to take your parent function, which is here. And where's the vertex of the parent function? At the origin. So that subtract 3 tells me to do what to this graph, to every point in this graph? Move it vertical shift. Vertical means go up and down. So I go what? Down 3. So what is my vertex then? 0, negative 3. So your vertex is 0, negative 3. So this vertex is 0, negative 3. Okay? Now once you find the vertex, then that's where you go 2 points to the right, 2 points to the left. That's all you do. All right, so I'm going to locate the vertex. I'm going to use the same grid. So here's my vertex right here. What is the x value for this vertex right here? What's the x value? What's the x value? 0. The x value is 0. So let's pick 2 points to the right and 2 points to the left. So give me an x value that's to the right of x equals 0. 2. All right, so if x is 2, I'm going to use a t-table for those. If x is 2, I get y equals absolute value of 2 minus 3. What's the absolute value of 2?
2.
And what's 2 minus 3? Negative 1. So I plot the point 2, negative 1. So 2, negative 1 is right here. All right, now think about what we just did. I went from the vertex, I went 2 units to the right, correct? What was my y value?
-1.
Negative 1. So I'm going to go 2 units to the left, and my y value better be what? Negative 1. So let's see. So remember I went 2 units to the left. So 1, 2, then let's, to the right rather, and then let's go to the left. 1, 2. So if x is negative 2, let's see what we get. Watch. I get y equals absolute value of negative 2, subtract 3. What's the absolute value of negative 2? And what's 2 subtract 3? Negative 1. So you see you get the same y value. All right, but again, I want 2 points to the right, 2 points to the left. So give me another x value. Give me another, 4? All right, if x is 4, I get y equals, so wherever we see the variable x, I plug in 4. So I get the absolute value of 4. Subtract 3. What's the absolute value of 4? And what's 4 subtract 3? 1. So I plot the point 4, 1, which is here. All right, now remember what I did. From that vertex, I went how many units to the right? 4. I went 4 units to the right, and what was my y value? 1. So I'm going to go 4 units to the left. 1, 2, 3, 4. So that means x is what? Negative 4. I better get what y value? 1. The idea of symmetry. So let's check. If x is negative 4, I get y equals the absolute value of negative 4, subtract 3. What's the absolute value of negative 4? And what's 4 subtract 3? 1. That's what we said it should have been. And then all you do now is just draw your graph. Again, what's the shape? V. So you get this. Right? And so notice again, let's think about the idea of the vertical translation. So here was the parent function right here. To graph the absolute value of the x, subtract 3, I have to go what? Down 3. 1, 2, 3, and there's the graph. Okay, so it does overlap this one. Okay, let's look at this. Suppose we had the absolute value of, let's say f of x equal absolute value of x plus 7. Absolute value of x plus 7. All right, now I need for you to think about, is this a horizontal shift or a vertical shift? A horizontal translation or vertical translation? Vertical, because the number's on the outside of the parent function. So here's my parent function. This number's on the outside of it. So that's a vertical translation. All right, now am I going to take the parent function and go up 7 or down 7? Up 7. Okay? All right, so now next thing you do is determine the vertex. What's the vertex? The vertex is not at the origin. Where's the vertex of the origin for which function? Okay, answer my question. Someone said the origin. The origin is the vertex for which function? The parent function. That's not a parent function right here. That's a parent function plus 7. So then you take that, so now you're in your mind, you're saying, well, I'm going to translate it up 7 units. So if you had the origin, your vertex is now moving up the y-axis. How many units?
7.
So what's that vertex then?
0, 7.
0, 7. 0, 7. So if you look at your grid, at that parent function on the grid paper again, so your parent function. So I'm trying to graph the parent function plus 7. So I have the absolute value of x plus 7. So it's actually 8, I think, right?
No, it's 7.
It's 7. So then I go what?
Up 7.
Up 7. 1, 2, 3, 4, 5, 6, 7. So in your mind, you have this vertex that's moving up. So actually, every point of the graph is moving up 7 units. So the vertex is 0, 7. So now we're going to pick 2 points to the right, 2 points to the left. So first of all, plot your vertex of 0, 7. So give me another x value that's to the right of this vertex.
3.
X is 2, x is 3. We'll do 2 and 3. So if x is 2, I get the absolute value, y equals the absolute value of 2 plus 7. What's the absolute value of 2?
2.
And what's 2 plus 7? 9. So I get 2, 9. So I plot the point 2, 9. 2, 9. Now, once you know one of those points, then you can get the other one by using the idea of symmetry. So if I started the vertex to get to this point that I just plotted, I went 2 units to the right, correct?
Mm-hmm.
And what was that y value? 9. So then I'm going to go 2 units to the left, which gives me x is negative 2. What's going to be my y value? Better be 9 still. And you can check it if you want to. You don't have to, but if you want to, you're going to get, if x is negative 2, I get y equals the absolute value of negative 2 plus 7. What's the absolute value of negative 2?
2.
And what's 2 plus 7? Get 9. That's what we said it had to be. Now I need one more point to the right. Give me another x value. Someone said 3 earlier. So if x is 3, let's figure out what we get using the t-table. I get y equals the absolute value of 3 plus 7. What's the absolute value of 3? And what's 3 plus 7? 10. So I'll plot the point 3, 10. 3, 10, which is here. So let's plot the symmetry of it. So from the vertex, I went 3 units to the right, correct? And what was my y value?
10.
10. So from this vertex, I'm going to go 3 units to the left, 1, 2, 3. And what's going to be that y value? 10 as well. So let's check it. This is x equal negative 3, right? So if x equal negative 3, I get y equals the absolute value of negative 3 plus 7. What's the value of negative 3? And what's 3 plus 7? 10. Right, and then you just draw your rays. Now make sure they're rays. Some students have a habit of making a mistake and just drawing lines. Those are not lines. So don't draw lines like this. This is your vertex, right? So that's where those 2 rays meet. All right, and so there's the graph. Y equals absolute value of x plus 7. And in your mind, it's very easy to see. You have your parent function, which is at the origin, like this. And so this is the absolute value of x, the blue graph. So to get the absolute value of x plus 7, I shift it up 7 units. And notice I get this. All right, let's look at this one. Suppose we had, suppose I had f of x equal absolute value of x minus 6, like this. All right. Now this time, okay, so again, always ask yourself, is this going to involve a horizontal shift or a vertical shift? Horizontal. Because the number's on the inside of my parent function. See, if it was this, then that would involve a what? A vertical shift. So you first of all you have to recognize whether it's a horizontal or a vertical shift. So this could be horizontal. So there's a horizontal translation. Now when I say horizontal translation, what I mean is that I'm going to take my parent function, I'm going to move it horizontally. That's what that means. Okay, so basically what's happening is this. I want you to think about this. So here's my parent function, okay, right here. The vertex at the origin. So if I want to graph this one right here, then that means every point of the graph, I'm going to move it which way? To the right 6 units. It should look like this. 1, 2, 3, 4, 5, 6. That's what it should look like. And remember, horizontal is where you think counterintuitive. So you see that -6? Think the opposite. +6. So then you go to the right 6.
Can I ask you something that might not make any sense? Is it because is that an absolute value sign still, or no?
Is what an absolute value sign?
The parentheses?
Where do I have, you mean this?
No, X minus 6. The one on
The
the
absolute
outside,
value sign, yes.
This?
to the left.
Yeah, those are absolute value signs. I said the absolute value of x minus 6.
Okay. Well, that just makes so much more sense in your head when you need to move it, because the absolute value of -6 is still 6. So that would be why you move it to the right 6, because it's still.
Okay.
Okay. It just makes it easier.
All right. Okay, so, all right. So what's the vertex going to be? 6, 0. Okay, 6, 0. So you plot the point 6, 0. Okay, now you pick 2 points to the right, 2 points to the left. Give me an x value to the right. 8. All right, if x is 8. Now remember, I want you all to notice this. To get that 8, I'm going how many units to the right to get 8?
2.
2. Okay, keep that in mind. All right, so if x is 8, I got y equals absolute value of 8 minus 6. What's 8 minus 6? And what's the absolute value of 2? 2. So I plot the point 8, 2. 8, 2. Now use symmetry for the other one. That's on the other side. So if I went 2 units to the right, what was my y value? 2. So if I go 2 units to the left, my y value better be what? 4. Your y value, not the x. I see what you're saying. The x is 4, but what's the y value? 2. Y value is 2. No, it's okay. You're fine. All right, so let's check it. So remember, I went from 6, I went 2 units to the right, I got 8. That's what this is, right here. And my y value is 2. So I'm going to 2 units to the left, which x is 4. My y value better still be what? 2. And you can check it. You don't have to check it, but you can. So if you check it, let x be what, 4? I get y equals the absolute value of 4 minus 6. Now be careful. Make sure it's mathematically correct. What is 4 subtract 6? So this becomes the absolute value of -2. What's the absolute value of -2? 2. All right. Now give me one more value to the right of the vertex. Give me something. Huh? 10? All right, if x is 10, I get y equals the absolute value of 10 subtract 6. What's 10 subtract 6? So what's the absolute value of 4? 4. So I get 10, 4. Use the idea of symmetry. It helps. So notice, though, from that vertex, to get to 10, I went how many units to the right? 4. 1, 2, 3, 4. So I went 4 units to the right. I got my y value to be 4. I'm going to go 4 units to the left. 1, 2, 3, 4. I'm going to get my y value better be what? 4. All right. But what's the x value when I went 4 units to the left?
2.
2. So check it if you need to. It's a good idea to check it. So plug it back in. If x is 2, I get y equals absolute value of 2 subtract 6. What's 2 subtract 6?
-4.
-4. What's the absolute value of -4?
4.
4. All right. And then don't forget to graph it though. Draw your rays, and there is your graph. That's all it is. So it's very similar to what we did last class period. The idea is the same, except the shape is different this time. All right, let's do one more with this, and that's going to be this one. So y equal the absolute value of x plus 5. Y equals the absolute value of x plus 5. All right. So again, ask yourself, is this going to involve a horizontal or vertical translation? Horizontal. Why horizontal? Because that 5 is in the inside of that absolute value function. It's inside that parent function. If it was on the outside, then it would involve a vertical shift. Now, since it's a horizontal shift, think counterintuitive. All right. So remember, horizontal shift. So basically, the parent function, where's the vertex understood to be in the parent function? At the origin. So in your mind, you have this at the origin, and you got to ask yourself, I know it's horizontal shift, but am I going to shift it to the right 5 units or to the left 5 units?
It's still inside the function, but yet its absolute value. Do you maintain the absolute value and move it to the left?
You always think counterintuitive.
Okay.
All right, counterintuitive.
Always.
Counterintuitive.
Even if it's absolute.
It doesn't matter. The absolute value is a function. Think counterintuitive. You're gonna understand why a little bit better next semester. Think counterintuitive. So if you see plus 5, you're gonna think what now? -5. So you can go to the left 5. Okay. So you go to the left 5. So in your mind you have this 1, 2, 3, 4, 5. So your vertex is 5, 0
-5.
or -5, 0. -5, 0. All right, so you plot that point right here. Now, if you make a mistake and you think 5, 0, you're going to catch yourself because at some point you'll be using that t-table to help you. So you can notice that something is wrong if you did make the mistake and say it was 5, 0. Okay, so give me a point to the right of -5. -2. All right, if x is -2, if x is -2, if x is -2, I get y equal absolute value of -2 plus 5. What's the absolute? What's -2 plus 5?
3.
You do that first. Move order of operations. What's inside the grouping symbol? Now, what's the absolute value of 3? 3. So I plot the point -2, 3. -2, 3. Right here. Okay? All right. Now, I need one more point to the right. Oh, well, let's do the symmetry. So to get to this point, I went from the vertex, I went how many units to the right?
3.
3. So hence x is -2. And then my y value is what?
3.
3. So I'm going to go 3 units to the left. 1, 2, 3. Hence x is what? -8. I'm going to get what y value?
3.
3 as well. Okay, and you can check it if you want to. You plug in -8 for x. Plug in -8 for x. I get y equal -8 plus 5. -8 plus 5 is?
3.
Nope. -8 plus 5 is?
-3.
-3. What's the absolute value of -3?
3.
3. So you see we get the same y value. Just do one more pair. What do you want to use? X is what? Give me something.
-3.
-3. All right, if x is -3, I get y equal the absolute value of -3 plus 5. You do what's inside the absolute value bars first. What's -3 plus 5? 2. And what's the absolute value of 2? 2. So I plot the point -3, 2, which is here. Now let's do the idea of that symmetry part. So from that vertex, I went 2 units to the right. And what was my y value? 2. So I'm going to go 2 units to the left, hence x is what? Negative 7. My y value better be what? 2. Check it. Check it. Make sure it's correct. So if x is negative 7, I get y equals the absolute value of negative 7 plus 5. And what's negative 7 plus 5? Negative 2. What's the absolute value of negative 2? 2. Okay? And then you plot that point, which you already did, and you draw your line. I mean, you draw your ray, your V. Okay? All right. Now, notice that one way to catch yourself to see if you did make a mistake, you remember how we asked ourselves, is the vertex going to be 5, 0 or negative 5, 0? Suppose you made a mistake and you said 5, 0, right? That's a mistake, correct? Okay, you can always check it. Here's what you do. You can see right away you know it's wrong. 5, 0. Well, if x is 5, what's 5 plus 5? I don't get what? 0. So you know something's wrong. It cannot be 5, 0, because when x is 5, what's my y value? 10. So it has to be what? Your vertex has to be what instead? Huh? Negative 5, 0. What's negative 5 plus 5?
0.
0. There's your 0. All right, so you can always verify your vertex by just plugging that number in and see if you do get that 0. That's right. Okay, so that was basic review of last class period. So remember last class period we spent a lot more time on graphing the quadratic functions. So this time we didn't, because a lot of it was mostly review from last class period. It's just that the shape was different. Okay, now